All right, we'll go for it then. Okay, so my name is Brian Pugh, and this is Alma Madsen, and we're both work for a company called Lucidchart that we're going to talk about a little bit today. But the main point of this talk is we're going to go over how to build large JavaScript applications and still keep them performing well and maintainable and keep your sanity. So we're going to use Lucidchart as kind of a case study of doing this. We'll talk about what that is, but first to give you a little background, what we're going to be talking about in this talk is how to build large web applications using JavaScript. So when we talk about a web application, we're talking about something like Lucidchart. It's not a website where you go from page to page, click on links and go from page to page. Pretty much you load the application, whether it be Lucidchart or Google Docs or something like that, and it's one page. This is it. You basically hit this page, and all the rest of the interaction is happening dynamically. You can drag things out here. The application itself is similar to Microsoft Visio, if you're familiar with that. Has real-time collaboration, you're drawing all sorts of things here. But it's not your traditional website of clicking on links going from page to page to page, but building an actual interactive web application where it's like a native app, but running in the browser. When you're building that kind of an application, there's some challenges to that and figuring out how to do that on the web. And so if you look at something like an application like that, a web application like Lucidchart, what are your options? Usually the first things people think about when they're talking about building that kind of a web application are browser plugins, right? They're going to use some browser plugin to build that application. The first one in this space was Java, right? Way back in '95, applets were going to take over the world and we're going to have all kinds of rich browser experiences because the applets were going to make it fantastic. But it didn't work out real well. Applets have never really caught on because there's some real downsides to applets. One, if we built Lucidchart using a Java applet, first of all of our users have to have a JVM on their machine and the plugin installed. And that's like about a 13 meg download now. So it's a pretty good barrier to entry for people just arriving to your site and needing to get like this 13 meg download. And then they actually, once they download it, they have to install it and endure about 4 or 5 minutes of Oracle advertising about how awesome their database is, which means nothing to my consumer customers, right? They don't even know what they're talking about. And so it's not a great experience from that perspective. And although Java was built with the idea of cross-platform support and all, in today's world, where we've got mobile, we've got tablets and everything, you're really not likely to get a JVM in your browser on an iPad or on one of these things, or at least the vast majority of your users on those types of devices wouldn't have access to a JVM. So for us, for Lucidchart, applets weren't really a great option. So there's also Flash, right? Flash is another browser plugin that people think about when they think about building these rich web applications. Flash is a lot better than Java in that it's not such a huge download. I think it's only like 1.5 meg or something like that. And Adobe's much better about not throwing advertisements at people while they install the thing. And most people have Flash installed, so it's a little better in that sense. But it also suffers from some of the same limitations. If you want to run on iOS, if you want to be able to distribute to more than just PCs, and more than just people's desktops, right? Mobile devices, iOS, Android. There's some support for Flash with Android, but Adobe's made it pretty clear that they're not really going to support Flash on mobile going forward in any strong way. So again, for us, Flash didn't seem like a great option either. Most of our competitors have gone with Flash, and some of them are now going off of Flash because they found they've run into problems trying to do something with that sort of thing. There's Silverlight. That's Microsoft's answer to this idea, but it has, again, same set of problems, right? You want to run on iOS, you want to run on Android, or even on Linux for that matter, you're going to run into some problems if you choose Silverlight. So for us, when we looked at it, at Lucidchart, none of the browser plugins really seemed like the right solution for what we wanted, which was ubiquitous. We wanted to create this diagramming tool that people could use on any device, anywhere, very, very low barriers to entry. The other option is GWT, or GWT, or Google Web Toolkit, however they like to say it these days. That's another thing that people are looking at, which, if you're not familiar with it, this is the idea that it's a project Google put out there that you write the code in Java, and then it compiles it to JavaScript. So it puts a layer of abstraction there so that you can write it in Java and you don't have to worry about JavaScript. So it's an option. When you look at it closely, though, it has some limitations as well. One is that you have that layer of abstraction, so you can write it in Java, but you're a layer of abstraction away from the metal of the browser, right? The language of the web, the language of the browser is JavaScript, and you're putting yourself at another layer of abstraction between the browser and the latest APIs that the browsers put out, the latest things they do. You're going to be one step behind because you have to wait for GWT or work around GWT to get to it. And so it has some disadvantages there, and the other disadvantage is even Java as a language has some real downsides. If you're working in this kind of environment where it's an interactive web application, there's a lot of event handling and that sort of thing, and Java does not support functions as first-class citizens or closures, which is a real downfall in that kind of environment. So you're paying a pretty big cost to move to a Java environment as well as the turnaround time. It's a little bit more of this compiling going on between each step, so it slows it down a little bit. So GWT didn't seem like a great option for us either. So the other option is just to write a ton of JavaScript. Just embrace the language of the web and say, this is what it is, I'm going to write a ton of JavaScript, and that's what we do at Lucidchart. We write a ton of JavaScript. And when I say we write a ton of JavaScript, just to give you some idea, we have well over 100,000 lines of JavaScript now. Quite a bit over 100, closing in on 200,000. It's just shy of 200,000 lines of JavaScript in our application. It's worked on by over 8 engineers constantly, so we have 8 engineers constantly working in that code base of JavaScript. It's a code base that's been refactored, features added for about 2 years now, so it's not a static code base either. This is kind of what I would call a large web application. When you start talking about this sort of thing, you're not talking about 5,000 lines of JavaScript, but you're getting into 30,000, 50,000, or in our case, getting close to 200,000. You've got multiple people working on it. You've got a code base that needs to not just last for a few months or 6 months, but for years and years. This is programming at large, and this is the kind of thing we want to talk about here. And how can you do that? Because when I tell most people this kind of stuff, their reaction is something like this initially, like, what did you do to deserve this awful punishment of having to deal in that kind of environment? But there's legitimate reasons why people have that reaction, because there are some real shortcomings in JavaScript. JavaScript has very limited support for namespacing and dependency management. Most of the languages you deal with, Java or C# or whatever it is, they have real easy ways to create namespaces, packages, organize your code into these namespaces and packages, and then say in my other files, hey, I depend on this, this, and this. I can import this, this, and this, or depend on this, this, and this. And it makes it really easy to organize your code. And we're familiar with that with most other languages outside of JavaScript, of having that sort of namespace and packaging. JavaScript doesn't give you much to help out there. It gives you very limited visibility controls as well. Again, most languages have like a private keyword, where you can say, I want to encapsulate this is a private variable, it should only be viewable inside of this object. Almost all the languages provide that. JavaScript, you can simulate that with some tricks, but it's enough cognitive overhead that most people don't do it. So you sort of lose some of that ability to encapsulate your data. There's no type system. So type systems have some, not having a type system has some great advantages, having a type system has some great advantages. And my experience is the more you get into this programming at large, where there's lots of people, lots and lots of code, and a code base that needs to live for a long time, having a type system really starts to become more and more valuable in that kind of environment. There's a certain class of errors that you're guaranteed you don't have when you have a type system. And there's a certain amount of readability that you get from a type system that you lose when you go to a language that doesn't have that information. Templating. A lot of JavaScript programming is generating dynamically, especially if you're creating a web application like I described, where we're not going page to page, but we're just dynamically updating the DOM. You're generating a lot of HTML, a lot of DOM elements. And so you end up with a lot of code that can be hard to read if you're just doing string concatenation of all these DOM elements or just doing that sort of thing. So you need some kind of a templating language to help you out there, and JavaScript doesn't provide it out of the box. And finally, there's the browser differences. So we've all probably built things where it works great in Chrome, it's working great in Firefox, and then you fire up IE and the whole thing just falls to pieces, right? So you have that struggle of, when you're writing in straight JavaScript, you have to deal with the fact that it behaves differently depending on which browser you're working in. So these are some real shortcomings, and then these are the reasons why a lot of people kind of look down on JavaScript and say it's a horrible language, I hate to have to work with it. There's some real valid points that can be made for the limitations of JavaScript. But there's also some hope. There's some things that we can do to get over these challenges. And we're going to talk specifically about Google Closure Tools. So Google Closure Tools is a project, it's an open source project. Google internally created these tools and then open sourced them about 2 years ago. Not quite 2 years ago, it was a Google I/O 2 years ago, so it was about this time. And basically it was Google realizing that they were going to be creating a whole bunch of web applications, like the kind I just described, right? You can see them out there now, Gmail, Google Docs, Reader, all these applications. And seeing these limitations of JavaScript, Google decided to put together this project to try and overcome some of those limitations that we talked about. And in so doing, they ended up kind of with, they call them the Google Closure tool set. There's really 3 pieces there. There's the Closure compiler, Closure templates, and the Closure library. And you take those 3 together, and kind of what you do, the way you work with the Closure library is, what you want out the bottom is your optimized JavaScript. And your inputs into this are, you write your own application code over here. So this is where I write my application as one input into Google's Closure compiler. The Closure library itself, this is a library provided by Google, and we'll talk about what that's about. It goes in with the compiler as well. And finally, you create your application templates, run them through the template compiler, and then the output of that goes into the Closure compiler as well. What it spits out, when you put all those inputs together, is this very, very optimized JavaScript. So that's, we'll go through in detail kind of what all that means, but at a high level, that's kind of the way the tools work together and how they work. And the first thing that we'll talk about is the Closure compiler. And I'm going to hand it off to Alma to talk about that.
All right, so the Closure compiler is what you saw in the last step there, that these 3 components kind of come together. It does a lot of things. It's more than just a minifier, although that's one of the great things. You can get a really concise, obfuscated output. But it also can help the compiler know, or it gives you a method to provide hints so your compiler knows what you're trying to do. For example, there's several annotations that you can use all throughout your JavaScript. So a lot of these terms you're familiar with from other languages, you can use this private keyword or these extends or this type keyword in your JavaScript to let the compiler know more specifically what you're doing and how it should treat your code. So as Brian talked about, one of the things with JavaScript that can be a really good and useful thing and can also hurt you when you get in a big project is the dynamic typing. Here's a sample function here, make AJAX request. You have 4 parameters here. There's no information of what those should be, and so you could really pass in whatever you want there, and if you don't handle it correctly, your application could crash. Then, there's static typing where you know exactly what things are. I am what I am, and that's all that I am, right? And so, like Brian talked about, there's advantages and disadvantages to both of these, but the Closure compiler with these annotations provides some help to you as a developer. So here's a sample of some code. So in the Closure compiler, you annotate before your methods and things. You can use these keywords. So here we have an add text method on this shape class. So you can see in the comment we're specifying what parameters, what type these parameters should be, so that when you go to compile this, if you're passing in this example, text as your first parameter of the method here, if you pass in a number there, it's going to alert you and say, hey, this expects a string. So a lot of the similar kind of things you expect from a compiler to catch. And like Brian mentioned, it's going to catch a lot of a certain class of errors, so you don't have to worry about that. There's also type expressions that you can, it's very rich. You can specify your own classes here. So we have this ajax.headers map. You can create your own classes, define those. You can specify I want this object, an instance of my own specific object to be a parameter in this method. And it will check to make sure that is, in fact, what it is, as long as your code is being called from within code that's in your project, right? Yes.
So is number actually a type?
Number, well, since in JavaScript there's no idea of ints versus floats versus doubles, right? So number is what the Clojure compiler looks at as any one of those things, right? It just needs to be a number versus a string, or an object or an array or something else, right?
Sure.
Yeah.
Is that just, so when it looks at the number, will it accept both number primitives and number objects, or just number primitives?
It's just number primitives. So if you in JavaScript, you could make you could extend the prototype on numbers and do all sorts of things, but it's looking for the actual, just like
Numeric
a
value.
equals 7, right? That's,
Okay.
there's a number for you, right? So in here, so I can kind of going through what some of these things mean here. So you have this equal sign after this line inside the curly braces. That just means it's optional, right? So you have optional. You can have nullable values. Here's a function that takes. You're passing in a function as a parameter that takes an AJAX return as its parameter. So you can nest these expressions as deep as you want. You can say, I want to pass in an array of objects that contain these keys and these types of keys and these types of values. So it can get you can get as specific as you want, which is really nice when it comes down to compiling. Here's an example of actually compiling. So this, from the last slide, if you call this.make AJAX request, you can see here's the output of the compiler. It says actual parameter 2 does not match formal parameter. Found string. You passed in my settings there as a second parameter, and it requires this AJAX header map, or undefined because it was an optional parameter. And it points out, tries to do its best pointing out where that is with a little upwards caret there pointing at my settings, the beginning of my settings. So it's very, very useful. I can't tell you how many times the compiler has helped us find bugs that would have been really, really hard to track down when we first started converting our existing code base over to the Clojure system when it came out 2 years ago. I was part of that project, and it has just been remarkable how many things you try. Obviously you're trying to write good code as it is, but the compiler will catch things that are just really hard to find in your browser. So the type annotations, you can add these anywhere. You can inline say, you can do like a casting, right? You can have some variable and you can say, using the comment markup, you can say this is an array, and the compiler will trust you that you know what you're doing at that point and treat it as an array. So you can do these annotations all over your code to really make it stable there. You can provide, the documentation is also really nice, just having that block at the beginning of each of your methods. Anyone else that's coming along looking at your code knows exactly what that function is expecting and what types those should be. And then you get this type inference at compile time to make sure that you're passing things around the right way. You change the annotation, you change how a method works, and it's going to catch any place. If you missed some other place that you're calling that method and passing the wrong thing in, it's going to yell at you. So it makes it really nice if you need to refactor your code as well. Another thing it offers is safeguarding your private variables. A lot of times when you have your classes, like Brian was mentioning, just the cognitive overhead in doing something like this. You have a person method and you have a name attribute on here, and so these are some things you might have seen where people are trying to make this name private, right? So you name it something else, underscore name inside, and you have these getters and setter functions and things, and it can get really messy when really you just want to make that private. And so with the Clojure compiler, you can mark that variable as private, and as long as you're in that same file, that same JavaScript file, you can access that and you can modify that. But if you try to do that outside, you're going to get this error here, right? So you get this access to private property not allowed here. This is some other file when you're trying to do that, and so you get a lot of the benefits there in making sure that your data structures are always intact.
So that gives you, we've seen you get a type system, you get encapsulation with the private annotation. Another thing that you get with a compiler is namespacing and dependency management. So most JavaScript applications, right, you start out with something like this, right? I'm making an application, I'm like, okay, I need some basic JavaScript in there, so I'll put that up in the header, grab the script. And then we work on it a little bit, and we decide we need a couple of third-party libraries, and we need 3 or 4 more JavaScript files, because we're starting to have more and more functionality, and I don't want to have just one huge file. So I get a few more out there, so that it grows some more, we add some more features, and some more features, and pretty soon it's a total nightmare. And this is not just theoretical. I just went out to a random site that has kind of a web application, did a view source, and this is all real. I just copied and pasted this directly, and it goes on for like another 20 or 30. So this isn't just a theoretical problem. This is the way people are managing their dependencies in JavaScript. And so the browser's going everywhere, right? It's grabbing all this JavaScript when you load the page, which is slow, and it's hard to even know. I mean, it's just a big mess there, right? And does this guy depend on that guy, or does this guy? Who knows? It's just all one big bowl of soup, and it's hard to tell what the heck's going on. So there's a better way, and what they did with Clojure is something like this. So this actually think of this as 3 different files. I just put it on one slide to kind of so you can see it really quickly. We have a shape.js, and we can say goog.provide lucid.shape. And there we're defining our namespace. It's similar to if you're in Java, you're creating a package, or if you're in C# a namespace. So you're declaring your namespace, and then you create the objects in that namespace. So in this case, we're going to make a lucid.shape and fill out the method there. In file 2, we'll provide lucid.line. Same thing, there's a constructor function, and we'll fill it all out. And then in file 3, which we'll call client.js, well, he's going to provide client.js, but he requires shape and line. If I try to use it now down here, because I require shape and line, I can say shape gets new shape and line gets new line, all that. I can access it. If I didn't have the require statement, then at compile time, the compiler would say, nope, you can't do that. It'll stop me and say, hey, I don't know what you're talking about. I don't know what this lucid.shape is, unless you specifically say I require that. And so it gives you a way, you start to namespace your JavaScript so that you can have some sense of where my dependencies are, what depends on that, am I making circular dependencies, because those tend to come around and bite me. You can start to actually reason about what your dependency tree looks like in a way that's really, really hard if all you've got is that, right? So at runtime, you basically include one file that contains all the dependencies. So I've got all these JavaScript files. They're all saying, sending their dependencies and everything. But just like a compiler for C# or Java, at the end of the day, I'll get one final executable out of it. Well, I'm going to get one final JavaScript file. We'll call it client.js in this case. And that's what's on my page. That's it. And that's got all the dependencies that I said all got pulled into this one file, so that I can just include that one thing. So what that means is at development time, when I'm developing, I can create as many files as I want. I can create hundreds of files. In fact, Lucidchart, we have well over 200 individual JavaScript files. But then when I actually load my application, I don't have to have 200 script tags to include all that JavaScript, right? I just have the one. So I can maintain, now I can have an organization of my code, I can have a package structure, I can create directories that match my namespaces, which is kind of generally what you will do is we'll have directories that kind of match your namespaces. So I can have a well-organized JavaScript code base with thousands of files if I want to, but at runtime, I only pay the cost of pulling all that stuff down once and the things that it needs.
So that's once per page. If you are using the single application, that's great, but if you have multiple pages that they have to navigate to, the browser has to hit and grab the different compiled version of the code.
Yeah, so you can make as many compilation units as you choose to, right? If you have, you could have 3 different pages and just only create one compilation unit and include it in all 3 and just call different things in the page itself, initiate it a little bit differently. Or you can make 3 different compilation units if that made more sense. So you have some flexibility there too, right? You can kind of decide how big you want to make your compilation unit and what makes sense. So in our case, actually, we actually do that. Our editor, where you actually are diagramming and doing the things, that's kind of one compilation unit. and what we call our document list, where you actually see all the diagrams that you've made, and you can create new ones and move them to folders and that kind of stuff. But it's kind of like a file system management. That's a separate Clojure compilation unit. So we actually have 2 compilation units out in Lucidchart.
Though they share a fair amount of code.
Right.
Right, and then yeah, within that compilation unit, I can still share the same underlying JavaScript. I just pick out the ones that I need with my good requires, right? And I'll get the right set for each one of those compilation units. That make sense?
Yes.
So minimizing. Let's talk about minimizing, because it's also a minimizer. So JavaScript definitely, it has to be sent over the network, and so you have to worry about bandwidth, right? And because of that, you get a lot of JavaScript libraries that start to use really terse names because they want to minimize the bandwidth usage. So you can see here's some examples. You know, $, span, comma, this. It's not real clear. I mean, it's very terse, but it's not real clear what that does. Most people are probably somewhat familiar with jQuery by now and have some sense of what that does, but that's because you sort of spent time. If you can kind of come up with this code new and you say, I don't know, $, span, this. I have no idea what that does. Or here's another example, $W, and then I got a string. Does anybody know what that one does? That's from Prototype. Anybody have any idea what that does?
Split on spaces.
Splits on spaces, yeah, splits on white spaces. And then this one is also from Prototype, and I have no idea what it does, but it's this. I didn't make it up. This is from their webpage. This is from their tutorial of the right behavior. It's to write stuff like that. So it was right off there. I just copied it off of their homepage. Well, not their homepage, but their documentation. So I mean, you get really unreadable stuff like when you write code like that. When you have libraries like that that you have to use, it gets really hard to read and maintain, especially. You know, if you're the maintainer and you're coming in 6 months after a whole bunch of code like that's been written, it's going to be a challenge to figure out what in the heck that code base is doing. So developers don't make good compilers. Nobody wants to read this, right? I mean, this is what I want my code to look like to minimize the bandwidth going down on the wire, right? There's no spaces, all my variables are a single name, lots of things have been inlined. This is what I want delivered to the client. But nobody really wants to be the guy who gets to maintain and read that kind of stuff. We don't make good compilers as developers. So with Clojure, you use names and make the code as readable as you can. Just make it a readable code. The compiler is going to minimize that. It can rename. There's different levels of how strong you want the minimization to be with the compiler. But essentially, it'll rename all your variables to very, very terse names. So the thing that actually gets sent to the client will have very, very, very terse names. Single, I mean, as much as it can, just single letter variable names. But when you're reading the code, you can read. You can make it a sentence if you need to. Compiler will minimize it. It not only minimizes it, but it actually removes dead code. So kind of back to the question you had, right? I can have a big code base, put in my go.requires for the things that I need. Anything that I don't actually require or actually call, it'll just rip it out. It won't include it in the final compilation unit because you're not actually using it. So I can make a whole bunch of common libraries. So suppose I made a library of Lucid common operations, right? And it has all sorts of things. And I'm making some compilation unit where I really only need one method from that thing. Maybe it's, I don't know, 5,000 methods on a whole bunch of different objects. Well, I can just include that one thing. I can call that one thing. And when I run it through the Clojure compiler, it's going to say, oh, I don't need all this other stuff. I don't need to pull all this other stuff in there. The only thing that actually got called in the real code was this one method. And it'll just pull that one method in. So it's not just minimizing, which, you know, there's a lot of minimizers out there. Clojure's not certainly not the first minimizer, but it's also this dead code removal. You add those things together, and you get huge decreases in your file sizes. I mean, like 95% smaller JavaScript than what's being written. So, really valuable. Templates. I'll hand it over to Alma again here.
All right. So the next step here, we've gone through the Clojure compiler and what it does for you and how it helps you out. The Clojure templates is the part that helps you actually create HTML or add stuff to the DOM. So this is a sample from our code base a while ago of creating some dialogue. You can see it's really messy, just concatenating a bunch of strings to make this DOM. Really easy to miss, you know, if you you need to close a div and you didn't, or it's just a horrible way to do things. But a lot of times in JavaScript, you know, what are your options, right? you're either doing this, or you're doing jQuery, you're doing some other thing where you're creating things and appending to, but you still end up with a lot of HTML in your code, right? So the Clojure template system seeks to help a little bit with that. So you can have a separate file where you just write straight HTML. You can use their curly brace syntax here to basically, insert whatever parameters you want or whatever values you want to pass in here, right? So you can, once again, using the same notations, you have these parameters, title, details, info, class. You start and end your template here, and you have a chunk of HTML, and you can put these variables in there. And what this does is it takes your template, and like Brian showed, there's 2 steps to the template. You compile the template first, and then the template gets compiled into your code. So this is what comes out of the first pass of compiling your template. It creates a method that has all your code in it, right? So it's still just as ugly at the end of the day, but you don't have to look at it at this stage. You can write it as regular HTML. It does a few other things, right? So it calls this escape HTML. You can see here, it's making sure that anything you pass in there is HTML escaped. You can prevent all manner of problems with cross-site scripting and just your own stuff. Just making sure that whatever you pass in there is going to not kill your application or have unwanted side effects. And so it produces this comment block, and this just gets included with another of your goog.requires for this template file, and then you can call that just as a method here. So you have this get element by ID, set your inner HTML to, you call that lucid.templates.invitation, you pass in an object with those keys and whatever you want to be passing into that, and you get your DOM. Pretty basic overview of the templates, but that's pretty much what it does. It's a simple thing. We used that a little bit. We found that one of the big problems with their templating system is that if you want to have interaction with your DOM elements, you still need to be putting a bunch of selectors and other things in there to get a hold of them back in the JavaScript side, right? So we have actually, we used it a little bit, and we've actually stopped using their templating system altogether. We've kind of put together our own system that we use that gives you handlers when an object is created and added to the DOM, and shortcuts to click, to bind click events and all sorts of other kind of events. But we kind of rolled our own because theirs didn't really fit with what the kind of level of interaction and the binding of events that we needed on our DOM elements all the time. But it is there if you're just trying to spit out a lot of HTML. It's a great tool to do that inside of your JavaScript. The next step here is the Clojure library. So the Clojure library is a big set of code of utility, methods, UI widgets, controls, rich text editors, event systems. So it's just a lot of libraries that Google has provided and included with this open source. For example, there's libraries that help you with date-time parsing, right? So you can take a date timestamp from your MySQL database and put it in there, and it will just parse it for you nicely as a JavaScript time object. And they've created their own Goog time object that gives you a bunch of other useful utilities. They have a lot of mapping functions for arrays and objects. A lot of things that you find yourself writing because they're useful, but they've already written a lot of these, and they already have the type annotations and everything you need to get compiled in your code really nicely. We use a lot of these. There's also the other JavaScript libraries. We use jQuery a lot. So we use the Clojure library tools as well as jQuery. Like Clojure tools they have their own selector engine and their own way to get the DOM elements, but we prefer jQuery, so we use jQuery for that. We use jQuery for our event binding and unbinding and that kind of stuff. So the Clojure tools, basically, you can use them with whatever libraries you like to use. There's a little extra work as far as helping the compiler know when you're referencing methods that are defined outside, because you you would then include, jQuery and your compiled code in your HTML document. But a lot of these things have nice community external files that you can include so the compiler knows what to do with that $, right? So for us, there's a big file that defines all the methods in jQuery and says to the compiler, don't mess with these, don't change the names on these methods, because they're all jQuery methods, right? So advantages of the closure library, like Brian was talking about, you don't get all these, $A, $P names. You get, nice verbose names that describe exactly what's happening. It's easy to look at your code, know that goog.array.map, it's easy to tell what that's doing. And so it's not trying to optimize it at the level you're working with it at. It's going to optimize it during the compiling process. And once again, you get this minimizing the dead code removal. You can include these libraries from the closure libraries, and if you're only using one method of the datetime class, that's the only one that's going to end up in your code, if that's all you're using. So that kind of sums it up, the closure tool sets, how they work together, and how they have really helped us make and maintainable a large JavaScript application. And turn the time back over to Brian here.
So, just to kind of conclude, the big JavaScript applications are on the rise. There's starting to be more and more where you see people abandoning Flash or abandoning applets or whatever and building web applications, not just websites anymore, but really trying to make rich, interactive web applications. So there are pain points, and our experience was Closure really, really helped. It was a great open source project to help ease some of the pain of building these types of web applications. And just to kind of summarize some of the places that really helped. There's communication and readability, right? That's going to be a big problem with a large JavaScript application. You get the types in there, it really does help communicate what does this method do, or kind of like Alma showed where maybe a method takes a callback, but the callback also takes a parameter. You can specify all that in the annotations for the type and get them checked and communicate to the next guy who has to maintain this thing exactly how this method is called, what should the parameter to the callback be that I'm going to provide here. You get the dependency management, we talked about that. A lot easier to understand what's going on than just a whole slew of script tags and who knows what depends on what. The templating, a lot more clear than appending a bunch of strings. And naming, right? You're not optimizing for, you're not trying to be the compiler. You'll get nice naming. So it helps a lot in maintenance, readability, and communication of your code base. Error detection helps. You put those types in, and you'll know when you call something wrong. You get a little more comfort in being able to refactor your code, because you'll get caught. It'll catch it if you do something wrong in your refactorings, if you need to change the method signature or something like that. Private variables. You don't have to go through the whole, like we said, we can do closures, and we can use a closure and the scoping of closures to kind of mimic the idea of a private variable, but most people in practice don't do that. If all they have to do is put an app private on there, that's good. That you can understand. You don't have to think about it. You don't have to restructure your code to make it work. It's pretty simple and it'll work great. The cross-browser library helps deal with a lot of the kind of errors you get across browsers. Rapid development, one thing we didn't mention, so this is putting a step between me writing my code and being able to run my code, right? I have to compile now. But when I'm developing, I almost never do that. So you can set it up so that at development time, all 200 JavaScript files or whatever, they'll just get included, like the big script thing, right? So when Alma and I are actually working on the code base, as we're writing new features or fixing bugs or whatever, we're not actually running the compiled JavaScript. We just have a way to set it up so that we're in non-compiled mode, and it includes all those scripts. So it's just as quick as refreshing. That's one of the great things about JavaScript is how fast you can iterate and how quick the feedback cycle is. You don't lose that. You still get that. But then once you've done the development, once you've built a new feature, run it through the closure compiler. Make sure that you've got your type systems right, your encapsulation right. You get all that, the minimizing, the renaming of variables. All that happens in the production runtime environment. But I still get super fast, rapid development environment. And then finally, performance. Minimizing, which again, it's not the only minimizer out there, but the dead code removal is really pretty cool. That's a pretty slick thing that you don't see in a lot of the other tools out there. So it's really helped us, across these three pillars. It's easier to maintain the code. It's found a lot of bugs, helped us prevent a lot of bugs, and it's helped us get a really performant website. It's a mature tool as well. It's being used on real projects. A lot of people, GWT seems to get a lot of press for whatever reason from Google. And a lot of people assume most of Google's stuff's being written with GWT, but these are examples of some of the things at Google that were written using the Clojure library. Google+, Gmail, Reader, all of these things, they're all using the Clojure library internally at Google. And like I said, we've been doing that with Lucidchart now. Our experience has been super positive as well. It's a mature, it's not a half-baked thing. It's a mature tool that you can use in a production environment and not get tripped up. So give it a try. It's out there at code.google.com. It's available. You can give it a try. All these things we've talked about, you can kind of ease your way in. You don't have to have all your JavaScript typed before you can use Clojure. You just put the types where you have it, and it'll start checking anywhere you put the annotations. So you can kind of ease your way in. It's not like you have to just shoot over to all types JavaScript, but you can gradually, that's kind of what we did, right? We had a whole code base that was not using the Clojure library, and then just slowly, we did kind of a big rewrite at first to kind of get the structure in place, but then we just slowly started adding more and more annotations. Anytime you edited the code, get more of them in there, get more of the types in there, to the point where now our code base, I think it's about 89, 83 now? Somewhere in the mid-80s. Yeah. We're about 85%. Every time you run the Clojure compiler, it'll tell you exactly what percentage of your code is actually typed. And we're somewhere in the mid-80s of how much of our JavaScript has actually got the annotations on it for the types and such. But it's been a great tool, really helpful, and encourage you to go out there and give it a try. And if this kind of stuff sounds interesting, building a big web application like Lucidchart, come talk to us after, because we could use some help building this kind of stuff as well. So if somebody's interested in this sort of thing, come talk to Alma and I afterwards. And I think we got about 15 minutes where we can take a few questions. Well, I think the next session starts in 15 minutes or half an hour?
I think it starts at half an hour, but
we have 15 minutes? Okay. So any questions? Go ahead.
Yeah, you said that you could run all the raw code in development mode. When you have things like your dependency management, Goo.require, those kind of things, how does that work when Goo's not part of JavaScript? Does it include a Google library at the top? Is that how that works?
Right.
Okay.
So it will be defined based on that, right?
yeah, there's one Goo file that you include, and you just include that Goo file and your base, like your client.js that has all the Goo.requires, and it goes through there. And when you call Goo.require, it looks up. It has a list of all your files and the class names, the namespaces for those, and it pulls those in and dynamically adds all the script tags. So cool. Yeah.
It's really simple to set up so that you can just work in that.
Yeah, it's really
like that.
easy.
Other questions? Yeah, go ahead.
Can you talk a little bit more about using it with other libraries? I mean, because a lot of code I write is like jQuery and stuff like that, and so like I can see, migrating it over slowly being a lot easier than saying, okay, I'm just gonna start fresh. So like, what kind of things do you do to help those interact with each other better?
Well, at a high level, there's two approaches you can take, right? I could try, we tried this approach. One approach is to say, I'm going to feed jQuery into the Clojure library along with my code. And let the Clojure compiler just go crazy on jQuery, right? And minimize out jQuery as well. That, in practice, didn't work so well for us. We found it was really hard to get it to actually get it all right when you have a huge library like jQuery being compiled in the same unit. So you can try and go to, we gave up on that route early on, like a year and a half ago.
Because you would have to go through jQuery and add all the type annotations and stuff to make it work, and that would just be a huge project by itself.
So instead what you do is you define this externs file. So you're telling the Clojure library, here's a set of external dependencies that are not going to be in my compilation unit. And like Alma said, you can get these files for most of the major libraries. There's a community that's going to generate, that's keeping maintaining them. And you tell the Clojure compiler, here's these external dependencies that are going to be outside. So I don't want you to go renaming any of the things that you find in this external file. Don't try to minimize out those names or anything. And that way, in your actual Clojure, in your actual application code, you just use jQuery. It looks no different than any other jQuery code you've seen. And the Clojure compiler just knows to ignore those things because you've said in this externs file, these are things I can't touch, I should not touch. So it's pretty straightforward actually. It's not too bad to just get it going. And like our code still has a ton of jQuery in it. Like we still actively add jQuery code in, and it hasn't been a problem.
Did that answer your question?
Yeah, so it sounds like it's basically just one file that kind of says, don't mess with this stuff, and then you can slowly migrate all the stuff over.
Yeah, you can just keep on using jQuery and set all your methods and however you'd like to.
So it still puts jQuery in your one bundle?
No.
Okay.
Not the way we're doing that. So we actually include the jQuery script tag, and that's why it's in our externs file, it's saying this is coming from somewhere else, not in our compilation unit. So we actually do include jQuery explicitly, and then our client JS or whatever it is, right? It has the rest of everything else. So we end up with 2 script tags, not one, because we use jQuery as well. But yep.
Is there good IDE support for the error detection and prevention as you're going along coding?
Not great. No, most of the IDEs don't do a great job. I use IntelliJ usually, or PHP Storm, or one of the IDEA, and it tries sometimes to look at them and will sometimes highlight a little bit, but I wouldn't say it's great. You're basically depending on the Clojure compiler to do that. There are some of the more recent frameworks. If you've heard of Play, the Play framework, which is both Java and Scala, it actually includes the Clojure compiler as part of it now. So you just refresh, and it'll as you hit refresh, it'll tell you your compiler errors right in there, because it's going to run the compiler as part of its web framework. So that's trying a little different approach to it, but I haven't seen great IDE support. We're using all of the IDEs actually at Lucidchart. We use
NetBeans,
Eclipse, NetBeans, IDEA, and one guy who's just stuck on Vim. So. So we're kind of all over the place, and everybody's just found ways to make it work for them. Nobody's had too much. You don't get all the additional. It would be nice if I had like code completion and stuff, right? It tries, but it's not fantastic. I wouldn't say. I thought somebody else had a question. I think. No, there.
Is it simple to do that type enforcement on hash arguments? So if you're going to take an options hash instead of individual arguments, can you enforce as easily those types?
No, because that's coming in as a string, and so that's kind of external to your application. It has no concept of what that is when you do a window location.hash.
No, I'm not talking about window location.hash. I'm talking about objects, JSON, hashes.
Right.
Oh.
Sorry.
Yes.
Ruby term.
Yes, definitely. Yeah, you can specify what. So there's a couple different ways you can annotate that. One of which is where you specify I want these keys, and so my key name should have a string. My key age should have a number, and you can specify that as much as you like. You can also specify and say I want my keys to be strings, and I want the values to be arrays or arrays of numbers or strings. Right, so, and you can go as deep as you want. You can say I want it to be arrays of objects with keys, strings, and you can go just deep as far as you want.
And you can also cast. So if I make an AJAX call and get back some JSON, and I parse that JSON into an object, I can put a cast annotation in there to say, all right, Clojure compiler from now on, assume this is a dog, or whatever type it is, right? So the equivalent of casting, that actually exists in there too. There's annotations to say, force it into this thing, whatever I just parsed, assume it's one of these. And then the Clojure compiler can assume it throughout the rest of the code base. And so if I cast it to be a dog, and then I call some method that takes a cat, we'll say, we can do that.
So a good example, we have to do a lot of the casting for when we use jQuery, when you do like a .val, if you're familiar with that, because you can either set the value or you can get a value with that. Clojure compiler doesn't know what you're doing. So if you're doing a .val getting it, you want to cast that to a string or whatever you know that is going to be. And so you'll have your little type annotation before that saying, I know that this is going to come back as a string or null.
Other questions?
You said it does that, the typing does it with your own objects too, right?
Yeah. Yep. Yeah. When you define when you define your classes and you do you define your classes with a constructor tag, and then when you do that, as long as you've done a goo.require on that file, you can use that type anywhere.
And there's other annotations that we didn't go over, like the @constructor is another one. So if you ever like try to call a function without the new keyword on something that has an @constructor, it'll say, oh, don't do that, because chances are very bad things are about to happen, right? That's not what you meant to do. There's a bunch of other annotations like that. I think we did show a list of them all there. We only went through a few of them, they're probably most useful. But there are other things out there like that, like @constructor one to name your classes and make sure you only call that constructor function with the new keyword.
And they do have some pretty good utilities for being able to create classes that inherit from other classes and extend other ones. I know there's other projects and code that does similar things, but theirs is pretty solid as far as we have like a lucid.item, and then we have a lucid block and line that extend item. And so you can pass it around and use, so you can say it's a lucid item all over in the code, as long as it has the same methods. You can define the methods on there, and you can do drawing a blank here. But, what's it called when you have like a parent class that's not ever instantiated?
Abstract?
Yeah, the equivalent of that, yeah. Everyone's called an equivalent library, but basically you can have abstract classes.
JavaScript class, yeah.
And it looked like are they basically Java docs? Like, has anyone tried to actually pull documentation out of it, or?
Yeah, so we actually use Yahoo's YUI docs to generate some documentation for some external APIs we have. Had to do a little. Their stuff is a little different, and it's a little different from Java docs too, but it's pretty similar. So we were able to, in a matter of a day or so, get it so we could create some nice documentation.
So I was just thinking about when you say I have an external dependency and it's not Google Closure library compatible, does it just automatically throw it in the global scope then?
Yeah. So if you just include another file, yeah, it's going to be treated just the way as it normally would be there in the global scope. The reason you have the externs and stuff is so that the closure compiler knows not to rename those methods or those classes or whatever you're using externally. So it wouldn't, if you didn't have the externs file, for example, and you're using jQuery and you did a $.each, the compiler might turn that into just C.
Okay, so
it's gonna.
So with your externals, can you not say, I have this view or this view model or something, and it depends on jQuery, so you get what I'm saying, where it's just like it knows that when I'm using the $sign in this file, it's jQuery, it's not prototype or whatever else I want to use.
If it's in your code that goes into the compiler, then it knows, like, one of the things in the externs file is saying that the $sign is a jQuery object, right? And so then you can have all your jQuery methods in the externs file saying there's all these methods on jQuery object. It has all the annotations. These are the parameters you expect. This is what you expect returning. And so in your code, it just doesn't change the names on those, and it knows how to treat it internally.
It's really just a list of variables to not touch. Don't mess with these ones because they're outside our compilation unit, so we can't mess with them.
Okay, but like when you want to use jQuery, do I have to require it, or does it just exist?
Oh yeah, no,
It's
sorry.
just there.
Oh, so it exists in
If it's in your
every
there's
file.
one externs file for each compilation unit that you have,
Oh,
and if it's in the externs file, it's always there.
okay.
Do you back this up with any kind of formal testing, unit tests?
We have a unit testing framework that we ended up kind of using ourselves. The Closure library actually comes with its own testing framework. The problem we ran into with their testing framework is it doesn't test it in compiled mode. and we wanted to test it in compiled mode, so we just put together something. I mean, really it took us a half a day to throw something together to actually test it in compiled mode as well. So we just kind of have our own little framework that we use for unit testing that will make sure we can test it both non-compiled and compiled. I haven't looked actually for a long time to see if they've made any difference in the testing framework. Maybe they've made it so you can do it in compiled mode. I haven't actually looked, but like I said, we've got something that's just been working happily, and we haven't even thought about it for a year, so we haven't had a reason to go back and see if they've made much progress on that front.
But they do update regularly their repository.
Right. It's an active project for sure. All right, well, I think that's about all of our time. Unless there's any other questions, if there are, maybe just come over and talk to Alma and I, or if you're more interested in what we're doing at Lucidchart, come talk to us as well. Thanks a lot for your time.